We're going to solve a couple of equations where the variable is sitting in the exponent. Kind of big picture. Eventually, when you see variables in an exponent, you're going to think of what's called logarithms. But we are nowhere near logarithms right now. So we're going to use what's called the one-to-one property. The one-to-one property says if you can get the base numbers to look exactly the same, then the exponents are equal to each other. Right now the base is 4 and this one, the base is 8. And so I'm going to force them to be the same. So if I force them to be the same, we're looking at these numbers and trying to think like, can I use 2 times 2 times 2 times 2 or 3 times 3 times 3 times 3? So for 4, what we could do is we could turn the 4 into 2 to the second power because they're equal to each other. So I just picked the 4 out and stuck in 2 squared, leaving the x minus 1. Then I want to think of how can I rewrite 8 so that it also has a base of 2. And 2 times 2 is 4. And 4 times 2 is 8. So with this one could be rewritten as 2 to the third power. But notice, see how the bottoms there, those base numbers are both 2 right now? That's what I'm trying to accomplish. Now from here, I have power to a power. Multiply. So if I multiply the 2 through here, then this is going to be 2. And then 2 times x is 2x. And 2 times negative 2 is negative 2. And this still equals 2 to the third. We forced, see how we have bases that are the same? So if the bases are the same, then we can set the exponents equal to each other. So I'm going to take the 2x minus 2 and set it equal to 3. Add 2 to both sides to finish. We're just trying to get x by itself. And then divide both sides by 2. And we end up with 5 over 2. Okay, so here's just a couple more really quick. In this one, the number 125 and 5, we want to get them to both be the same base. And 125 is the same thing as 5 to the third power. So I'm replacing the 125 with 5 cubed, and now those 5s are the same. Then from there, power to a power, multiply. So I can do 3 times 3 is 9. 3 times negative 2 is negative 6x. Now that the bases are the same, I'm going to be able to set this exponent equal to this exponent. Finish solving, so letters on one side, numbers on the other. Just add over the 6x to move the x's to the right. That gives me negative 3x, bring down the 9. Then divide both sides by negative 3 to get rid of multiply by negative 3. And 9 divided by negative 3 is negative 3. Okay, so one more, just quick one. The numbers 64 and 32. You may not know it off the top of your head, but you just start trying. 2 times 2 times 2, see if you can get there. If not, 3 times 3 times 3, see if you can get there. And it turns out for 64, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So I can write 64 as 2 to the power of 6. And I can rewrite 32 as 2 to the power of 5. Notice we have 2's there. That's our goal, is to make them the same. Then from there, power to a power, multiply. So 2 to the 6, still that. 5 times x is 5x. 5 times 3 is 15. Now that we've forced the base numbers to be the same, then we can set our exponents equal to each other using this one-to-one property. And then finish solving, letters on one side, numbers on the other. So move the 15 to the other side by subtracting it. And then I still have 5x there on the right. And 6 minus 15 on a good day, negative 9. Get rid of times 5 by dividing by 5. And so I end up with negative 9 over 5 as my final answer.